suppose you have a piece of knowledge and somebody asks you about it, and somebody says, I don't believe that piece of knowledge. Can you explain that? Can you explain that knowledge to me? Why do you believe that knowledge? If you can't explain that knowledge to the other person, then maybe it's not really knowledge, but it's something that you believe for some reason. Maybe it's because somebody told you that it was true, right? So that's so if there's knowledge. So let me say it this way: like knowledge that you cannot defend against objection. Okay. And then there's knowledge, there's maybe real knowledge, which is knowledge that you can defend against objection. Okay. Right. So knowledge that was given to you without explanation. Right? Just something that you believe because somebody told you that it was true. Okay, so what I usually use as an example is the Pythagorean theorem. Right, the Pythagorean theorem. So what's the Pythagorean theorem? Who can tell me the Pythagorean theorem? What's the Pythagorean theorem?
Like 3 squares plus 4 squares equals to 5 squares.
3 squares plus 4 squares equals 5 squares. I'm not sure. Do you mean, so the Pythagorean theorem is about triangles, right? Right. It's about right triangles. You have some side lengths A, B, and C, right? And so what does the Pythagorean theorem say? So can somebody tell me what the Pythagorean theorem says? I'm sure you know it. You know it, right? What the Pythagorean theorem tells you something about the relationship between these things, right? That. Yes.
A squared plus B squared equals.
A squared plus B squared equals C squared, right? Right. That's what it says. If you have a right triangle, then the square of the hypotenuse equals the sum of the squares of the other sides. Right. I'm sorry, what's your name, please? Di Jiang. Okay. Di Jiang. Okay, great. Okay. So, right. Okay, so everybody knows this. So suppose that there's a small child, okay, and the small child comes up and says, why should I believe that? Why should I believe the Pythagorean theorem? I don't believe it. How are you? I don't believe the Pythagorean theorem. Okay. So now it's up to you to convince this child that it's actually he actually should believe it. How do you convince the person? Like, here's an objection. Why should I believe that? You've just said it to me. Why should I believe it? Okay. Can anyone defend the Pythagorean theorem against this very simple objection? Does anyone know a way of explaining, like how suppose you have there's a small child and says, I don't believe that. Why should I believe it? Can anyone think of how you might convince the small child that it's true? You just say, oh, I don't know. Somebody said it was true when I was in elementary school, and this is how I learned the Pythagorean theorem. When I was in elementary school, somebody said A squared plus B squared is equals C squared, and I said, okay, right? Okay, I believe it. I trust you. But you see that's not really knowledge, right? That's really superstition. Somebody bigger and older than you tells you that it's true, and you say, okay, it's true, right? So that's what one would call superstition. So here is one way. Here is one way of defending the Pythagorean theorem. one way of defending the Pythagorean theorem. Okay, and this is actually from an old Chinese manual on from the Han Dynasty. I think it's called like the Zhou Bi Suan Jing. Anyway, so this is 2,000 years old. I found this in an American textbook some years ago. Okay, so what you do is you say, okay, let's take four. Somebody gives you a triangle, a right triangle, and you say, okay, I'm going to take 4 copies of that right triangle, and I'm going to put them together. Okay, so I take another copy of the same right triangle, I take another copy of the same right triangle, and I take another copy of the same right triangle. Okay, and I put them together. Okay, so each of these is the same right triangle. I put them together like this. Okay, and then I ask, what's the area? Okay, so what's the area? C squared. Okay, so C squared. Okay, so again, I'll be the skeptical child. Okay, so the skeptical child doesn't believe anything you say. He says, why is it C squared? Why is it C squared? Why is it C squared? Jiajin, you look like you want to talk. Go ahead.
No.
No, you don't want to talk?
Every side of its
Same. So they've got the same lengths, right? Same lengths. It looks like it might be a square. If it's a square, then if this is a square, then that's good. Then this is C squared. Is this a square?
Yeah.
Why?
Same 4 copies.
Same 4 copies. Yeah. So
Because it's 90 degrees.
it's 90 degrees. These things are 90 degrees. Why are these 90 degrees?
No, I mean the B and A.
B and A are 90 degrees.
Yeah.
Yeah.
Because it's just a 90 degree triangle.
This is a 90 degree triangle. That's true.
It's
Yeah.
at 490 degrees, so it's fair.
Okay. So I mean, these are 90 degrees. Yeah. So this thing in the middle is a square. I believe that. Why is the big thing a square?
Because the middle is square, so because C and A plus B and C is 90 degrees.
Yeah. So this plus this is 90 degrees, right? And we have the same thing, right? This, right? So since this and this is 90, then this is 90 also, right? So you've got 4 90 degrees. It is a square. Okay, good. So it's C squared. Okay, that's good. Okay. So that's thinking of it like this, right? C. It's side length C, right? You've got the square, so the area is C squared. There's another way of thinking about the area, right? What's the area of the triangle? What's the area of each triangle? What's the area of each triangle? AB over 2, thank you. Right? 1/2 AB, right? And you have 4 of them, right? So the area also equals 4 triangles plus this thing in the middle, right? What's this thing in the middle? What's the area? What's the area of this thing?
B minus A.
B minus A squared, right? So plus A minus B squared. A minus B, B minus A, whatever. Okay, right? Is everyone okay with that? Right? You see it, right? This is A. This length is A, and this length is B. Right? So this length is A minus B. Right? This length is A minus B, and so the thing in the middle is A minus B squared. Right? Okay. So what does that tell you? That tells you that C squared is the same thing as 4AB, right, plus 4 triangles plus the area of the little square in the middle, right? And so that tells you that there's a relation, right? There's a relation between the outer edge and the inside and the other edges, that c squared has to be a squared plus b squared. Okay? And so this is one way of defending the Pythagorean theorem. Okay. So just to give you a sense of how you want to think about how you want to be thinking about mathematics. Okay. So any questions so far? This you don't have to know this. I'm just trying to give you an idea of how we're going to approach the knowledge in this course. Okay. Any questions? Any questions? No? Okay. Okay. So that's good.
Yeah.
Good. Okay. Okay. So So let's start off with just a quick review of ideas from calculus. Okay. So some ideas from calculus. So this is just a review. Okay. Okay, so I'm not going to go into, really go into too much detail. Okay, but I'm just going to sort of skim through some ideas. Okay, so so the first thing I'm going to mention is something that sometimes that often isn't mentioned. It's something called the extreme value theorem. The extreme value theorem. Okay, and what it says is that if you have a function f, a function on AB. Okay, so you have a function on AB. If f is continuous, oops. If f is continuous, then f attains a maximum on AB, and 2, f also attains a minimum on AB. Okay. So the picture is, you have some function on an interval, right? And maybe it looks like this. Okay. And so you see that there is a place where the function hits a maximum value, the function attains the maximum value, and there is a place in this picture where the function attains a minimum value. Okay. Okay. And this wouldn't happen, doesn't happen on the open interval AB. So if we throw out the endpoints, then this doesn't necessarily happen, right? In this picture, if I threw out the endpoints A, B, right, then I'd have something like this, right? And there's no place on the open interval AB where the function reaches its maximum. Okay, there is a place where it reaches its minimum, but there's no place where it reaches its maximum here. Okay. So anyway, just remember, right? If you have a function, if you have a continuous function on a closed interval, then there's some place where it reaches a max, and there's some place where it reaches a min. Okay. And this is actually a very deep, deep property of numbers, of real numbers. Okay. Okay. Second thing is the notion of derivative. Whoops. Derivative. Okay. So what's a derivative? Right. You have some function. Right? You have some function. Somebody tell me what a derivative is. What's a derivative? You know what it is. Otherwise, you should not be here. What's a derivative? Maybe I should choose people at random. I can choose people at random. 20. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what's a derivative?
I'm not sure.
You're not sure? Okay. Does somebody, the slope? Okay. So, right. So you have a point C. There's this thing called the derivative, right? F prime of C is geometrically the slope of the tangent line. At C. Right, the slope of the tangent line at C. Right. Can anyone give me a different definition of the derivative? This is sort of a intuitive idea. Right. Can somebody give another definition of the derivative? Right. It's F prime C is the limit as h approaches 0. Does anyone know the rest of this? What's your name, please?
Xiaoli, Xiaoli.
Xiaoli?
Yeah.
Huh. I don't have you on my list. What's your last name?
Li.
Li. Oh, your last name is Lee.
Yeah.
Huh. I don't have you on my list. This is.
I will talk about it.
Okay. Sure. Maybe you've just registered. Okay. Does anyone know the limit definition of the derivative? Everyone sees? Yes. Oh, FC. Just C? Over? Over H. Very good. Right. The limit of f of C plus H minus f of C over H, right? You've seen this before, I hope. Right. You take right, you take the slope. You take the slope of this line. Here's C plus H. You take the slope of this line, right? This is the slope of this line, right? And then you let H go to 0, right? You let H go to 0. You should have seen this before. I hope you've seen this before. Everybody close your eyes for a second. Close your eyes again for a second. Raise a hand, raise a finger if you have not seen this before. Okay, open your eyes, please. Thank you. Okay, so a couple of you haven't. That's all right. That's all right. Maybe you've only seen like this notion, the geometric way of thinking about it. I'm not sure if we actually will need this. We actually will need this. So if you haven't seen this before, come and talk with me, and I'll try. We'll talk more about it. Okay, because this is a very important idea. It's a very important idea. Okay. It's not. We're not going to be using it all the time, but we will need it. We will need it. Okay. Okay. So there's you have this function, right? So you have you have a function, you have this thing called the derivative, right? So the derivative of f at c, right? This thing here, right? The derivative of f at c. Okay, and then there are some rules of differentiation. That rules of differentiation that you should know. First, let's say if I have two functions and I differentiate them, then what do I get? If I take the derivative of a sum of functions, then what is that? F, yes, you get f prime x plus g prime x, right? Right. The derivative of a sum is just the sum of the derivatives, right? So basic rules of differentiation, right? The derivative of the sum is the sum of the derivatives. If I have some number, so suppose you have some number alpha, a real number. Okay. Suppose you take your function and you multiply it by that number. If you differentiate that, what do you get? Go ahead. You get the number times the derivative. Great. Great. And what's your name, please? I'm sorry, I've forgotten. Anxini. Okay. And what's your name, please? Wangdi. Okay, great. Okay. Right. If you have if just like this, right? What's the derivative of x squared? You know what the derivative of x squared is. What is it? 2 times x, right? If I take the derivative of 5x squared, what do I get? I get 10, right? That's 5 times 2x, right? You get 5 times the derivative, right? The derivative of 5 times the function is 5 times the derivative of the function, right? That's what we're saying here. The derivative of some number times the function is that number times the derivative of the function. Okay. So this property is called linearity. It has a name, linearity. Okay. Other things, the product rule. Can somebody tell me the product rule? What's the product rule?